Hello, we are from Team Chandak. I am Sharat and this is Mayank. We'll be talking about our prototype, which we'll be calling a Terminator electric generator. Our prototype basically generates electricity both during the day and the night on the surface of the moon. And I'll let Mayank speak more about our prototype.
Thank you, Sharat. Consider this to be the basic model of a prototype. It's not a cylindrical can, it's a cuboid. So we use thermoelectric generators. Now the thermoelectric generators generate electric current based on the temperature difference between both its surfaces. So these are just small chips. So we'll have the 4 of these chips installed on a prototype, 2 on the upper surface and 2 on the lower surface. So these are the TEGs, or this TEG and this TEG will be used to generate current during the day, and this will be used to generate current during the night.
Yeah, so the cavity between both the surfaces, that's the upper surface and the lower surface, is filled with gas xenon, and it's inert and it has the least thermal conductivity, which is our best option, and it lies just above vacuum, and vacuum is not a practical option, it's just an ideal case. So we'll be using xenon as the cavity, the layer inside the cavity, and I'll let Mayank speak more about the...
Yeah, so one more point is the side layers of a prototype are actually mirrored. So these will reflect any radiations falling on it to prevent the xenon heating up. So consider this to be the front view of a prototype. These 4 are the thermoelectric generators that I talked about. These 2 are used to generate current during the day. These 2 are used to generate current during the night. So during the day I'll explain the phenomenon. First, let me explain the thermoelectric generator. The upper surface, if there's a temperature difference between the upper surface and the lower surface, the semiconductor Bi2Te3, which is bismuth telluride, generates there'll be a flow of electrons between the upper and lower surface. This flow of electrons can be recorded by the voltmeter. So this is just the expanded view of this layer, which is the thermoelectric generator. So this is just the expanded view. So I'll explain the day phenomenon. During the day, the surface of the moon heats up to 123 degrees Celsius. Now the xenon gas maintained at 0 degrees Celsius can go up to plus or minus 5 degrees Celsius. So during the day there will be a temperature difference between both the surfaces of TEG, which is around 120 degrees Celsius. So this will help us in generating current. This will develop a potential difference that will generate current. And the upper surface of the TEG, I'm talking about the left hand part of our prototype. So the upper surface is heated due to direct exposure of sun's radiation. So this can go up to 123 degrees Celsius, the upper surface. And again the xenon is maintained at 0 degrees Celsius. So there will be again a temperature difference of around 100 degrees Celsius. So this will generate electric current. Now both the TEGs over here are actually inverted. So we have a warmer surface over here and a colder surface over here. I'll let Sharat explain the night phenomenon.
Just as the way the phenomenon of the day occurs, the same way the same way the prototype works during the night. The only thing here is the surface inside the prototype is the warmer surface, and the surface outside is the colder surface. So during the night, the temperature goes up to minus 153 degrees Celsius during the span of 14 nights. And the xenon gas doesn't allow the temperature, the heat transfer between the upper and the lower surface of our entire prototype. So basically, the temperature difference between the upper surface and the lower surface of our bismuth telluride crystal, that is layered on the bottom surface of our prototype, will be around 200 degrees Celsius. So that temperature difference can be used to generate a voltage, like explained in this link up, and then we can use that voltage to generate current. And that current can be used to charge up a battery or a rover or anything we use in use in our future purposes. And now we'll be explaining the sustainability of humans or any other forms of life there in the moon.
So you can see the side surface actually mirrored to reflect the direct sun's radiation to avoid heating up of xenon. Now why is this experiment so important is because the main requirements for humans to sustain life on another foreign body apart from Earth will require power, food, air and water. Now we are basically concerned with the generation of power. Now the voltage generated from our experiment will help us in determining the thermal conductivity of the moon's surface, and will help us determine how much temperature difference produces how much voltage. Now the generated voltage at a span of different intervals will be uploaded to the rover through the S-band. So the experimental data will help us in designing the future prototype missions. During a future mission, we can optimize and generate enough voltage to charge batteries. These batteries can be used in any way from like long distance range antennas to life support system. So this is a very crucial and important experiment for human sustainability.
Yeah, so this is our basic model of our prototype. I hope you liked it. Thank you.
Thank you.